Hey guys, Mr. Riz here. So I'm here to help you out with the 1.5 notes. So this is going to be a fairly quick section because we're not going to get into all the kind of crazy little things that could happen, but we're just going to focus on what happens the majority of time. What we're going to look at are what's known as infinite limits. So a lot of times before, like when we had a graph that approached a region without bounds, meaning the graph like went up forever or went down forever, all we did was say like that limit does not exist. What we're going to do is just be a little bit more specific about that. Now, the one thing that we are going to use is that we're going to use the number or the expression known as infinity. So one thing to make sure we understand is that infinity is a number value that just doesn't exist. We can't count to infinity because there's always going to be one thing more than it. So infinity, the limit still does not exist, but we're just going to be specific, whether that goes towards a positive infinity number or a negative. So if you look at this expression here, if we just look at the left and right bound terms, we can see like on a graph, as we get closer and closer to 2 from the left side, it keeps on going down and down without any bounds. It's not stopping. And from the right side, it keeps going higher and higher and higher. So we'd say the limit going towards 2 from the left would be going towards a negative infinity. Going towards 2 from the right would go towards positive infinity. So that's the big thing that we're going to make sure we can do. Now, if we look here on this graph specifically, we could have a vertical asymptote here at 1. Going from the left side, it's going towards infinity. Going from the right side, it's going towards infinity. So now we probably can say that the limit as we go towards infinity or go towards 1 itself, since they both match from the left and the right side, they both do not exist, but they both match at positive infinity, we can say that the overall limit is infinity now. Now something like this problem here, we can say the limit from the left side is positive and the limit from the left side is positive and the limit from the right side is negative. So still the overall limit just does not exist. Okay. The biggest connection between limits going towards infinity are the presence of vertical asymptotes. So vertical asymptotes is where f of x approaches infinity or negative infinity on any graph of that c. So we pretty much would just say the line x equals c is a vertical asymptote. We've done these before when we looked at removable and non-removable discontinuity. Remember, removable pretty much makes a hole in the graph. The non-removable is going to make a vertical asymptote, and we can use that later. So let's determine all the vertical asymptotes on this function here. So if we had the equation x squared plus 2x minus 8, okay, can we factor the top? All right, what two numbers multiplied together give us negative 8, add together to get 2, that'd be x plus 4 and x minus 2. Now the bottom, x squared minus 4, factors out to be an x plus 2, x minus 2. So we do have 2 points of discontinuity in this graph. We have a point of discontinuity at negative 2 and a point of discontinuity at positive 2. But the positive 2 does get removed from the expression. So the only thing that remains that is non-removable is this x when it equals negative 2. So we could say that there is a vertical asymptote at x equals negative 2. Now we'd have to look at the graph to determine whether that limit's going towards positive or negative infinity, but that's how we can determine the vertical asymptotes now. So let's do some more practice here and see if we can figure out what these are. So when we first look at a graph, we're going to see, can we have the denominator equal 0? Where it can. All right, we can have the denominator equal to 0 here when it equals 0. Is there any way to get rid of that? No, we can't. So we say there is a vertical asymptote at x equals 0. All right, so this one here, the next one, if we look at the bottom, we know we could have 2, would he make it equal 0, and negative 2 equals 0. Both of those cannot get removed from the top. So we say we have a vertical asymptote at both x equals negative 2 and x equals positive 2. All right, next one here. All right, t squared plus 1 is our denominator. So could that ever equal 0? Meaning, okay, if I minus the 1 over, and we would take the square root of a negative 1, which doesn't work. So we'd never have the denominator equal 0, so there'd be no vertical asymptotes for this problem. Once again, we can always verify any of these problems by just plugging these into a graphing calculator. All right, next we got 3 over x squared plus x minus 2. So let's see, that denominator would be x plus 2 times x minus 1. All righty. So that means we would have discontinuous points at -2 and +1, and both of those don't get removed. So we could say we have vertical asymptotes at x equals -2 and at x equals +1. So this is very similar to what we've been doing. Nothing new here. Okay. So let's go through next. You know what? We're going to skip the sines and cosines in this year. Look at the graph if we need to. All right. Ooh, this looks like fun. All right. The top factors to x minus 5, x plus 3. Now the bottom, what we're going to do is, can we split this up? We can take away an x squared from both of those, and we get an x minus 5. And we could take away a 1 from both of those, and we get an x minus 5. So we would get a expression of x minus 5, x plus 3 over x squared plus 1 times x minus 5. So if we look at our potential discontinuous points, we'd have one here at +5. And then here, could we ever make this equal to 0? X squared plus 1? No. Now, if this was x squared minus 1, we would have a discontinuous point at -1 and +1, but it's not. It's x squared plus 1, and that would be, so if we look at our discontinuous point, it would be at 5, would be the only point that wouldn't work, and that actually gets removed. So there are no vertical asymptotes. Okay. Last problem here. Let's look at both of these and maybe just kind of talk about them. So we're going to determine whether the graph has a vertical asymptote, is removable or non-removable at -1. So if we look, -1 on both of these does not work out. All right, we plug it in the bottom. Now, can we remove it or not? This top fraction, we can factor to an x plus 1 times x minus 1, meaning we can remove the discontinuous. So this would be removable. On this problem here, we can't factor the top. It just squares an x squared plus 1. And we can't get rid of that. So this would be non-removable, or now what we're going to refer to as a vertical asymptote. All right, guys, so this ends the 1.5. And in fact, this ends chapter 1. We're going to do a nice little lab activity after this to make sure we understand kind of the whole concept behind chapter 1 before we move on to chapter 2. And yeah, that should be it. It should be good. And if you guys have any questions, make sure you guys reach out and ask. But if not, I will see you next time. Bye-bye for now.